Well, the final project we're looking at today is RESOLV. It's a combined laser rangefinder and digital camera that automatically navigates around buildings to create a 3D photographic image.
RESOLV can be used to build a spatial model of surroundings for construction and property applications. The model is built up progressively, using a scanning laser rangefinder to capture the structure and a video camera to add the texture. The data can then be used to produce a 3D reconstruction of a single room or even a whole building to use with CAD systems. There are two prototypes, one manual and one self-navigating.
The way it works is quite simple. On the top here there's a laser device, a laser range-finding device, which is moved back and forwards in a sort of scanning, makes a horizontal scan, and then it slowly sweeps down to make a complete scan of the scene in front of the device. And then as the laser fires a pulse out into the world, it times the time it takes to come back, and that is then used to give an estimate of the distance from this device to the surfaces out there in the world. Now, what you get then is a picture, sort of two-dimensional picture, sort of depth map of distances to different parts of the world, making up a two-dimensional image. Simultaneously, up here there's a television camera which is also shooting a TV picture. So it takes a complete standard television picture of the scene, video picture of the scene, at the same time as getting the depth information. And so it's important to be able to transfer the device to different places and take a picture, a three-dimensional picture, and then the whole thing gets stored away. And when we've grabbed all these pictures from the different positions, they then, at a later stage, can all be put together to make a complete composite reconstruction. And that all goes on inside here. There's a standard PC down inside this box here, which receives all the data down these cables from the laser scanning device and the camera, and puts together all the different depth and video pictures that are required from the different positions to make a complete model, complete three-dimensional model for an interior such as this.
So, David, what's the difference between RESOLV and virtual reality? I mean, the output appears to be very similar.
Well, virtual reality is usually building a model of something that's yet to be built, and it's building it from the inside outwards, perhaps adding a few photographic textures at the end of the day, whereas RESOLV is reconstructing buildings that are already there and attacking them from the outside in. So with RESOLV we never actually find the internal structure, but we do know what it looks like.
Okay. Mark, now apart from being an extra in the Star Wars movie, how is RESOLV actually going to be used in practice, do you think? I
think potentially, David, the RESOLV technology has a number of applications that will be developed of relevance to both the real estate and construction sides of the industry. For example, the high-quality three-dimensional graphical output has potential uses in high-value sales and marketing of real estate. And in terms of building surveying and facilities management, the remodelling of existing buildings, and thirdly, perhaps as to permit high-quality presentations to planning authorities, particularly where there may be sensitive environmental concerns with listed buildings and conservation areas.
Is it going to put the surveyor out of a job, do you think?
I honestly think that's unlikely. I think we're always still going to need the surveying expertise to evaluate and handle the output of the technology. I think it does underline the important need for professionals, and in this case surveying professionals, to increase their understanding of technology and obtain a view on the likely applications that are going to come from it.